In this video I'm going to talk about how do you know how good your heat treat really is. I've got a Rockwell tester, so I test all my blades for hardness after I've quenched them, and I also test them after I've tempered them, so I know where they are on the scale. And I know that generally that 59 HRC gives you perhaps an optimum hardness for a Scandinavian grind knife. But if you had really overheated your knives and you'd caused grain growth, or if you had retained austenite, it's still possible to get a 59 HRC reading and still have a knife that isn't any good. So there's a way you can be absolutely sure, and it's dead simple, and it's very destructive. I know I look daft with these. I've got to an age in my life now where I need to have magnifiers. Well, I've always needed them actually, but I need them more and more now. So that's what I do. Every batch of knives I do, I test. I select one blade. In this case, it's going to be this one here, and I've got to see how the blade fails. Now, every blade, every knife will fail under certain circumstances. It's impossible for it not to fail. If you push it beyond its design, if you push it beyond its limits, the edge will fail, whether it's a good heat treat or a bad heat treat. But it's how it fails which tells us whether we've got a good heat treat or a bad heat treat. If it chips, then we look at the chip, and if the chip is symmetrical, then we can probably be sure that the heat treat is still good, but it just needs to be tempered a bit higher perhaps, so that it will fail to a roll rather than a chip, which is preferable for a Scandinavian grind, because a roll is easier to rectify than a chip. If it chips and the chip is more jagged and less symmetrical, then it points possibly to the fact that we've got grain growth and that we've overheated the blade, or something else has gone wrong. So I'm going to test this, and I'll show you how I test it. Here's a piece of it's actually a cold chisel, but it's very hard steel, and it's got a circumference. It's about 3/4 of an inch in diameter. There's a knife bevel, very coarsely ground rough bevel, and I've stropped it just to remove the wire edge, the burr, and I can rest the bevel on at the bevel angle, and then apply a bit of pressure and see the bevel deflecting. And then I can see it bouncing back. That's a good indication. But if I push hard enough and increase the bevel, increase the angle above the bevel, I can make the blade fail. And it's taken a lot of pressure to do this. And that edge is failing. It's failing to a roll, which is ideal, because a roll is very easy to fix. So I don't know if the oh crikey, that is not going to fail. Yeah, I'm pretty happy with that. In fact, I'm delighted with that. So I'm very happy with that. That test showed me a lot. It told me that the blade isn't too hard. It told me absolutely for sure that I do not have any grain growth or whatever anomalies in the steel. And I can be sure that the person that gets this knife is not going to experience any chipping with it. But having said that, I know also that it's not too soft because it didn't roll with ease. It took a lot of pressure, and I know also that the Rockwell measurement is around about 59. And I've tested my Rockwell tester with a calibration block, so I know I'm pretty accurate with that. So I think that's just about as good as it gets. The heat treat colours, you can see the true colour of the heat treat is this sort of a dark golden browny colour, but you get a different lot of a mixture of different colours on the blade, and then for example there's a bluey colour here. Now if anyone is used to oxidational colour charts, you'll realise that the blue colour indicates a very high temperature, over and above 300 degrees centigrade. But in this case, this colour doesn't indicate that at all. I've noticed that blades that have been treated with an anti-scale compound, ATP 641 I use, will come out with a bluey tinge, and it doesn't mean anything. It's not the true oxidational colour of the steel. And the reason that this has been brought to my attention was that a friend of mine, a local knife maker, Davey, he's been experiencing the bluey tinge, and I told him not to worry about it because it was to do with the anti-scale. So if anyone there is wondering, say, oh that's way too hot, it's not. It's actually how it should be. So anyway, I'm very happy with the outcome there on the destructive test. Now I can go back. I don't even have to do any remedial repair to this blade because it's not damaged very much at all. I'll simply go up to the next grit, which will be a 220, and then I'll grind it all the previous grit scratches out, and then take it up to its final finished grit. And then build the knife up, and you wouldn't even know that it's been subjected to a destructive test. The key to a good heat treat is getting your blades quenched down really quickly. So there's no hesitation, straight into the oil. A nice slicing motion. That's the blade submerged at the moment, and then goes the handle. And that blade should be unholdable. In next to no time. Now that'd be fully hard. around about 65 or maybe a touch more Rockwell HRC. I'll measure it later. Now I'll quench one of the bigger knives. This is a 4mm Classic. So again, I submerge the blade, slice in motion through the oil, and then goes the handle. As soon as that blade hits the oil, the cooling action of the oil causes the steel to shrink slightly, and that blows all the anti-scale compound off. So this is a bit of a thicker blade, but again it's cooled down very quickly, as you can see. Let's have another one out. That same slicing motion. Now, according to myth and legend, your quench tank should be aligned north and south. I can tell you that there's a load of nonsense. My quench tank is aligned because of convenient purposes more than anything, really. This direction is east and west. And the blades, some of them come out very straight, some of them come out with a little bit of a warp. It's going to be a fact of life that whenever you treat a piece of steel, especially long, thin, slender sections like knives, you can expect some degree of warpage to a greater or lesser extent. Sometimes you'll see the warp, sometimes it'll be so small you won't see it, but there'll be a warp there. But I don't worry about that these days. I've got ways to deal with all that. That's nice and cool now. So the blade is now cleaned up and placed above the kiln in a warm place to rest. Let's get the others out. It's really important to get that slice in motion. Because what happens when the hot blade first goes into the oil, into the quenchant, it forms a vapour barrier around the blade. The vapour barrier is basically an insulator, and it stops the oil from cooling the blade. So by moving your blade, especially when it's red hot, going into the oil first of all, by moving it backwards and forwards, you disrupt that vapour barrier and allow the oil to have access to the steel and thus cool it in the correct manner. You've got to drop it at the right temperature rate to affect full hardness. The oil I'm using is a special O1 quenchant. It's designed for O1 tool steel. It drops it at the right rate. So that's the blades in a warm place above the kiln, just resting now. Don't take any notice of that. on the back there, that writing, because some of that, it was just when I was testing stuff and I wrote that down. I think it's really important to mention that I like to leave my knives to rest a little bit after I've quenched them, because the quenching process, it is just that, it's a process. It takes a little while for the blades to convert fully. I know after I've quenched a knife, for the first minute or so after you've quenched it, you can still bend it. But if you leave it for say 2 or 3 minutes and then try and bend it, the chances are it will snap. So the conversion from austenite to martensite doesn't happen instantaneously. The blades have really cleaned up nicely. I'm going to test them for full hardness now. I've got a partial bevel on this knife, but I'm going to test it just above. I'll be grinding all that away, so you won't see where the test mark is made. So that's the preload going on. Just to line it all accurately. So the little hand is on the red, the big hand points up to the C. The outer scale is the HRC scale, the inner red scale is HRB. We're looking for 65 around here in the end, but this is the preload. Now I'm going to impart the main load, and I'll expect the main load to end somewhere about this point here, or maybe a bit further. There we are. So the main load has been imparted. Not stopping there is telling me that I'm going to have a good hardness already. Just wait for the full measure of the weight to be applied. Can see no more movement of the handle can see no more movement of the little hand. Can see no more movement of the large hand. It's come to rest, so I can unload it now. And we're looking for that 65 plus, and here we can see we're well above the 65. So that blade is fully hard. I'm testing a classic now. Every knife I build, I test for full hardness and also for final hardness. Looks like the hand is settled, so I can now unload it, and hopefully we're going to have 65 plus, and again we're above the 65. It's the next day now, and the blades have been through 2 temper cycles, so I'm just checking each one to see where they are. I'm looking for them to be around about 59 HRC at this point. Set that up. So we'll stop up here a bit more now. The steel is softer. You've trade-off when you temper steel. You remove some of the hardness. The steel becomes a bit softer, but you also increase the toughness. So I'm looking for that to swing round to somewhere about 59 ish will do. And that's pretty close. So this machine, it measures to an accuracy of about 1/3 of a Rockwell point. What I like to do also on the Rockwell testing is do a comparison, because the machines, especially in this environment, you know, I'm only in a workshop here. It's not a clean room environment. So I like to run a test piece, a test block. And I've got a test block here, and this gives me a comparison. Now, I know this is a measured 60.9 HRC. So I'll take a measurement from this, and if this is low, I know my blades are low. If this is high, I know my blades are high. And if it's reading around about 60.9, I know I'm more or less there. So we'll see if we'll see how accurate the Rockwell tester is. And again, I go through the same process. It's important that you do exactly the same things that you do when you're measuring the blades as when you're measuring the block. You allow it to settle and leave it for the same amount of time. So let's see where we are with this. And we're 61. It's measuring 61, so I'm 0.1 of a Rockwell point out. So my blades are all around about 59 Rockwell, so I'm very happy with that. You can see perhaps from the indents on the test block, I've made lots of tests over the years. Well, here they are. This is the end of the metal work on the knives. Very happy with them. They've been hand finished and the tangs have been tapered. All I need to do now is fit the scales and the liners, shape the handles, finish the handles off, finish the spine of the knife off, leather work, etc. So I've got some spectacular pieces of wood to go on these for, a mixture of different varieties. So what I'm going to do is probably do another video next week showing these knives as completed articles, as completed knives. Yeah, I'm quite happy with those.